Hello, my name is Cy Cannon, and for the past year, I've been doing research in the psychology department with my research mentor, Dr. Wozniak, over the moth effect. For those of you that are unfamiliar with the phenomena, it's best described as when a driver sees a flashing light, stares at it and fixates on it, and ends up inadvertently drifting towards the source of the flashing light. If this drifting causes an incident or a collision, it can obviously have major implications for traffic safety. However, the moth effect in its entirety is shrouded in a lot of mystery. It's referenced quite a bit in journalism and in popular culture as being the cause for why people clash or have a crash with state patrol vehicles with their flashing lights on. But very little empirical evidence is out there to support these claims. Hence why Dr. Wozniak and I wanted to conduct this evaluation. For our first experiment, we wanted to see if flashing lights and a manipulation of light contrast conditions would cause a decrease in cognitive ability. So we had participants come in and complete a search and find task using the children's book Find Momo. They were instructed to go through the images that they were presented and click on Momo the border collie in order to move on to the next one. 18 of the images had a red and blue flashing strobe light, 18 of the images had a white strobe light, and then 18 images served as a control condition with no strobe light present on them. To manipulate the light contrast effect that we wanted to see, we had one set of the images be fully bright, and we had a separate set of images be at 50% brightness to increase the contrast between the strobe itself and the picture and its surroundings. We hypothesized that the presence of a flashing light would make response time slower, and we also hypothesized that with the light contrast conditions, a dimmer picture would take longer for the participants to find Momo, significantly longer. Unfortunately, across the board with the strobe lights versus no strobe lights and the light contrast conditions, we did not see any significant results. However, the data did support our hypotheses in terms of their patterns. Strobe lights led to longer response times, and dimly lit pictures led to longer response times as well. Since we did not see significant results with that study, we moved on to a second that included a 3D driving simulator. We had participants come in and drive in this simulator to see if they would have different driving patterns when they were exposed to a police cruiser with flashing lights versus no flashing lights. Unfortunately, we did not see significant results with this data as well, with very little differences in position data being seen. Overall, with both studies, we did not see any significant results, but we'd like to keep doing research into the moth effect just to see if we're manipulating the wrong variables or if we could alter our experiments to maybe achieve significant results.